I'll go
Right.
next.
Yeah, you. I'm talking about you.
Oh, okay, cool.
That was Ryan, wasn't it?
Yeah, so maybe going off of, considering it like an art. An art is something that usually we're discovering as an expression of something found inside, and the place where it comes from is sort of mysterious. Whether it's built into the nature of the personality, which might be genetic memory and an accumulation of ancestral instinct and all sorts of things, combined with an impression that we receive from the world and the way that we're nurtured in our environment and all these things. And then there's something inside of us. Like good art is an expression of something inside that again extends outward to somebody else can receive it in. And they say, this is the value that we find in the art. Is that something's being transmitted through the creation. It's sort of a mysterious and paradoxical how it arises. But it's a way of connecting one to another again, like love. But I think back to like the mechanistic. I'll try to stay away from the computer analogies, although I think they're like really helpful modern conventions that we have added to our language. The more that we interact with computers, the more we seem to be able to even understand the world around us better. The way that we see these binary functions happening with ons and offs and yeses and nos in the transistors in the computer. I think that the universe seems to me to work something like that. There's actually a very simple binary at the bottom of everything that's going on. There's, I don't know if you go all the way down
someone
to
put commands into it. Someone put commands and rules into it. And there's no way we could have developed that computer from the position of solipsism, obviously.
Hold on.
This is where me and this guy diverge.
I'm cooking.
Well, at least let me get next, bro. You're cooking, but hold on. Because you just said something that goes against what you were saying previously. So you're saying that
I'd like to
fundamental level.
Hold
on. At the fundamental level that there's a binary. Is that what you just said?
Yeah.
That's known as an absolute, which you just debated against for like an hour.
Yeah, this is where I diverge with him, Lion. So just to make that point come in. There's a lot that
we know you don't believe in binary.
No,
sorry,
I don't think I argued against absolute. You
said solipsism was your
So
position when you were debating for hard solipsism.
Well, I've been expressing
you can tell he hasn't it all figured out yet, Lion. So give him some slack. He's kind of. You are kind of helping.
I haven't got to express it yet. I haven't got to. You're pulling it out half baked. All right, it's not ready yet. Let it cook, because I'm going. Let me cook. I'm going somewhere. The binary I'm referring to is that I'm not saying that there's this and that and they're separate things. That's what I was saying before. That there's an underlying unity in thingness as a concept and separating one thing from another as a mental construct. But within the unity of all that is, there is also light and dark, there's hot and cold, day and night, there's life and death, there's before and after. These are the binaries that I'm talking about. There's up and down. There's these cyclical, there's seasons, there's the harmony of the spheres, everything like that. This is how I perceive it. All right, so from these fundamental, this binary relationship, it's basically the universe is sort of gendered, positive and negative, light and dark, hot and cold. There's this way and that way, there's forward and backward. So because of that, there's a consequential unfolding taking place that's sort of built into that binary relationship, that gendered masculine, feminine, or whatever at the root of the relationship between the forms, between the flowing of energy. I'm getting kind of like meta, but I'll bring it back.
No.
So it's okay.
So because of that, because of that, I'll land it real quick. I think the way that I see logic, bringing it back to logic is like, as you were saying before, that we're discovering words and concepts and symbols and then language from that we can use to map onto this reality that has emerged because of that fundamental relationship. In the same way that a river emerges from the water flowing down, and the water is, like sometimes we say in these types of conversations, it seeks its level. But that's a strange way of saying, because water doesn't have a seeking function. What water is actually doing is being drawn along the path of least resistance. Just based on that fundamental aspect of water's relationship with gravity or whatever the thing is that causes it to go down, it's being drawn along the path of least resistance. But over time, as that water continues to be drawn along paths, it carves out rivers and creeks and channels, and then ends up with creating seas. And then these rivers become paths that the water is drawn to flow down more and more. And so these fundamental aspects of nature create the creation of the river. There wasn't a creator of the river. The river is an emergent phenomenon of this binary force of up and down. And so because there's a down and the water seeks the path of the least resistance, which is down, then the river gets carved, and then the water goes through the river more and the river gets deeper. And then this is an analogy to things that we have of like paths of logic. So our thoughts now flow down these paths that have been carved by our experience, just like the water flows down the river. It's just our thoughts are going along the path of least resistance. And when we find one of those where we don't find resistance, this works every time, we call that knowledge. So it's just like a river of thought.
Real quick.
Incorrect, though. The laws of logic are, we're here before you, before language.
Exactly. And so my response to that is very, very quickly. The river existed before the water flowed. The path that the water was going to go
water
down.
Always existed.
It was an inevitability based before the water, even before there was any water to flow down the hill. The river path was there, and the water found it because of the nature of.
Hey, I gotta challenge you. I gotta challenge you real quick, dude, before we move on, because you started to bring up binary, up and down, and you don't even believe in an absolute up and down in the you're heliocentrist, right? Like there's no absolute up and down on the globe.
It's a relationship.
There's no absolute up and down in the globe.
Well, what we call up and down is it's in and out, away from the center. Yeah.
Well, yeah, see, in my world,
so it's in relationship to
and uniform. Up is absolute and uniform through all of reality, and so is down. It's not relative or subjective.
Right. You think in that term, exactly.
Away from the ground or down to the ground, it's the same.
And in my reality, there's a clear distinction between good and evil. There's no mixing them. Can't turn evil into good and good into evil, salt into bitter and bitter into sweet. It's absolutes. Male is a male, female is a female, X and X, X and Y. There's no, solipsism. It's not about sophistry either.
It's A is A, so that's law of identity as well.
And the study of DNA throws a whole wrench into this whole entire conversation at this point, because there's also a language there encoded.
But it doesn't really throw a wrench, though. It's the same thing. That's a river that was forged.
It is the same thing, because just as you make a curry soup and you want it more spicy, you changed it and imbued it with something else, just as you with the DNA altered the original. So you have an archetype for the original, and you altered it, or created a change. You could say that there is also an archetype of that which you already changed it into. And now we're also getting into terminology of faith.
No, there's inputs that we can't explain. There's inputs that are coming into DNA that we can't explain where they come from. It's not an adaptation process. These inputs are just put in there, and it's constantly being interacted with.
That's a paradox. That's an idea. It would be fluid then.
How do you know that?
That's what the science shows.
I don't think so.
And that show sounds somewhat like Anthony Fauci, trust the science kind of argument, Torah, and that kind of weird hearing that from you.
okay, if you're denying DNA at this point, then that's fine. You can do that.
I mean, come on. You know that's not what he said.
Yeah, you don't need to add more meaning of things that I didn't say.
You know, people use philosophy, don't even realize it's philosophy. Like, I heard you say the path of least resistance. I.e. Occam's razor, right? That's a principle. What's a principle?
That's not the same thing. That's not what the path of least resistance is.
I know it's there's more nuances regarding Occam's razor, but that's basically it summed up, dude. Unless you want to be pedantic.
Yeah, well, so I mean, if we wanted to use an analogy, that's fine. But what's the goal? If you're trying to get to the sea, the path of least resistance doesn't always get you there. So, in the same way, Occam's razor doesn't always get you to the right answer.
Right. Earlier, I heard you say that your model is more I forget how you worded it. I don't want to misquote you, but you said that your model is more. You say, dude, comprehensible? Is that the word that you use?
Yeah, to me,
you said it was more comprehensible, right?
I think
it has utility,
coherent. Yeah, I think it's more.
It's
coherent,
more coherent.
Yeah,
So people say this a lot. Oh, it has more utility. It's more comprehensible. It's more understandable, and they use that as a defense, right? But really, if you look at both models and you compare them, like everything, put all the orbital mechanics on one side for relativity, and put all the orbital mechanics on the other side for geocentricity, with no relativity involved, no spatial expansion, no dark matter, no dark energy, no elliptical orbits. Instead, you have there's actually models out there, and I know Witsit it can help me out with this, like the Neo-Tychonian model of the universe, where you can have all the orbital mechanics work out mathematically, and have a more elegant model that fits Occam's razor with less complexity needed to explain the natural phenomena that we see happening in the sky. And you don't need all of that.
Yeah, well, I mean, the problem is when we examine them, the reason that they're less complex is because they just have giant gaps. Mine might sound more complex because just mine is actually attempting to have answers, whereas yours seems easier because it just goes, I don't know, with the hard stuff.
No, it has kinematic and dynamic equivalent.
The thing is, bro, I'm not even fighting for this position. I don't like to fight for Occam's razor. I don't like that principle, to be fair. It's a faulty principle, in my opinion, because just because your model might be more efficient or more elegant doesn't mean that that's necessarily reality, right? That's still based off of a principle. Doesn't necessarily it's not necessarily 100% certain just because it's more efficient or more elegant, requires less steps. Because reality, if anything, is very complex.
Yeah, I don't think that's what proves it, but it's a nice feature. That's kind of like all I'm saying is that, I mean, just the same as the other fellow was saying before. The only reason I brought it up is because he said, well, we have a measurement of flat. And you don't have any measurement. And I said, all right, well, that's a nice feature of your side. A nice feature of my side is that my side explains stuff. Yours kind of is missing that. Mine has dynamics involved, and yours just goes, I don't know why it does that. It just does.
Drawback.
And that's
no, we got dynamics. That's what the Neo-Tychonian model is, bro. It's dynamics, and it also has kinematic. Though it's working off a spherical model, it's still a geocentric model. Now we're working out the sky right now as we speak.
Right. That's
these things are being figured out.
So that's what I'm. Yeah. So when you offer that one, it's like, well, what do you got for the sky? And it's like, well, we're working on it. And I go, okay, well, let me know when you got it, and then it'll seem more appealing.
What explanatory power does the globe have that flat Earth does not have?
Like why the things travel through the sky is a good one, like we were just talking about. And if you can quibble about whether or not you accept those explanations, but they are there.
What things are you referring to? Like you just that's
like the moon and the sun and the stars and the satellites and stuff like that.
Those explanations are kind of affirming the consequent, though. That's why
so
we
that's
don't
my
accept
point.
them.
So
They're
my point
logically
is like,
fallacious.
so again, you can quibble about whether or not you accept those explanations, but at least I have some, and they work for me. If you say they don't work for
but
you,
if
that's a
they're
difference.
if they're fallacious in their logic, why are you accepting them?
Well, that's your
right.
That's your claim, but I haven't seen that demonstrated to be true.
Yeah, we showed you affirming.
If you accept fallacious reasoning, that's user error on your part. And then if you say if you don't accept them, that's your problem. I mean, it's the same thing. They're equally they have the same truth value.
What part is affirming the consequent? With regard
for
to
example,
how the stuff
if
moves
you've
through the
heard
sky?
the argument like the 24-hour sun in Antarctica proves the globe, do you agree with that argument?
No.
Okay, so that would be
there
affirming
you have that. You're done.
an argument used.
No, it doesn't prove the globe, but it aligns with the globe system concept.
Right. We agree.
And then then I ask how it aligns with yours, I hear something like earlier I heard from a fellow, he was like, maybe there's like a wormhole Pac-Man situation going on.
Well, I mean, there's that. There's also the bipodal thing going on, which I don't know if I agree with. There's the single sun with the dome. That might be the refractive Pac-Man thing you might be talking about. Like, there's a couple different options. I mean, it's an apparent sun. That's all I know. That from my perspective. I can't speak for anybody else here.
Yeah, I'm.
But then, what is your argument then, Big Tech? What's your best argument for the globe so we could show you it's fallacious?
Yeah. I mean, we could do this forever.
Right.
It's always fun.
And that would be your goal, right? To present something that can be falsified, so a falsifiable argument, right? You'd want it to be falsified.
That's what I found that it's interesting is that if we go with any one evidence, right? If I say this to me means that, evidently this is true. So this is like a fact that lends credence toward the idea. I would call that evidence, presentable in support of a claim. And if any one of those,
we're claiming all of those are fallacious,
right? But the thing is, when you isolate one of them, and then if you isolate it on its own, you can find it's insufficient to explain everything, or there's an element to it that if you frame it in a certain way, then you can make it that it's affirming consequent, like this, therefore that. Like for example, but the thing is, it's like there are things.
Listen, we could tear them down one by one if you want. It doesn't matter. We'll tear them down. If you have one by one all fallacious proofs, you don't have evidence of anything.
Right, and you kind of have to go point by point. You can't say, because I know it's a globe, we did this thing, and that proves that it's a globe, and then we know this thing. You'd have to go point by point. So, for example, if the argument for motion is weak, and you can falsify it, then you don't have motion, you have a stationary Earth, right? If the argument for curvature is weak, and you can falsify it, then you don't have curvature. You'd have a stationary topographical plane.
Yeah, I haven't seen anybody falsify the motion. I've heard I'm familiar with Airy's failure and Michelson-Morley, but I'm also familiar with Coriolis and what happens with the sniper bullets, and I don't have good explanations for those. They seem to me to align, again, just like the 24-hour sun, it aligns with the globe concept, and I see other things that align with the globe concept. So none of them are something I can say definitive proof. And then we have all sorts of issues like, what I see you at a sunset, it looks to me like the sun's going behind something. I can hear you say that's fallacious. It could be something else. Okay.
So what is your issue with Aries in motion? Like, you don't think that Aries has anything to do with motion?
Well, you have to say that relativity is invalid concept in order to say that Aries proves there's no motion.
No, you don't.
All right, so if relativity is a valid concept, can't we have Aries failure and motion?
So even if you apply relativistic effects, Aries, you should still measure the angle change in the water telescope. I'm assuming you know about it, but even if you apply relativistic functions, there should still be an angle change in the telescope. There isn't. There's no angle change.
But I thought that the
argument
answer to
against
that is that
Aries that a lot of people bring up is, oh well, Aries was just trying to measure the ether, which he wasn't. He was rebutting Clinkerfuse, who said that you could measure the motion of the Earth by putting turpentine in a telescope, and he was refuting that.
It's funny. Turpentine's an odd thing to bring up for that, like, objective.
Well, I might not be remembering correctly, but Clinkerfuse put turpentine in the telescope, and then Aries responded to it.
Yeah, I know, right? That's what I'm saying. Like, wow.
Why
I could be
turpentine?
remembering
You know?
it incorrectly. You guys, if you want to look it up, I mean, Clinkerfuse.
No, we don't think you're
why.
wrong. We're just saying.
Why turpentine though? Out of everything out there, why that? What
We know what
specific qualities the turpentine has?
It's a medium. I'm not sure why he chose that one in specific, but the point was the point I was making was his claim was that he measured the motion of the Earth. Clinkerfuse claimed that, and then Aries was a response to that. So contextually, I mean, listen, the response to Aries is usually, oh, he was trying to measure the aether and failed, when everyone in science at that point assumed luminiferous aether because it makes no sense that there's like a not background medium. So again,
not background
why does
medium.
Aries not have anything to do with motion, and why don't you accept it as a valid rebuttal to motion, including relativistic effects?
Was that a question for me?
Yes.
I thought we were still on the turpentine thing. Wait, so but I'm under the impression, and maybe you're telling me I'm wrong here, that with the concept of relativity and a light having its own reference frame, I thought that that's why you can explain that there was no angular change.
So you'd have to say that both the distance in the telescope changes, as well as this, and it conforms to the speed of light changing in water, and you're saying that both of them change proportionately, and then it still doesn't work. So first you have to say that the distance in the telescope changes, and you also have to say that the speed of light, which is a constant, and a constant that, I guess it bounces around in the telescope and then it reaches the right, the eyepiece, the crystal at the bottom, and then it still doesn't work. There's no motion.
I don't get it yet. I'll have to think about that some more then. I don't know how to compute what you're saying because I don't really.
There's no angle change. There's no angle change there.
I have like a small diagram that shows like what.
So Steelman, the science, the mainstream science perspective. What would they say? What would Neil deGrasse Tyson say?
Neil deGrasse Tyson. I'm not going to get into Donut Boy, but PhD John, what he says is that Aries was about measuring the ether, and then I asked him if he read Aries, and he said no. But I read FlatEarth.ws and Wikipedia. I think he's read it now, and he has a rebuttal. But nowhere in it does it talk about the ether, and it's actually talking about Clinkerfuse's paper, which claimed that, he could measure the Earth's motion, right? And you'd expect like 30 kilometers a second or whatever. But there should be an angle change when you reach the telescope, and there isn't. So you'd have to claim that it's like say you ran across a football field, right? 100 yards, we'll say a football field, and it took you 30 seconds. and you ran across 2 football fields, and it took you 30 seconds, right? You might think that you're running twice as fast, but in reality, the 2 football fields contracted into one, and you ran the 200 yards in the same time, but the distance changed. Therefore, like the distance over time is speed. So like the speed of light didn't change constant because the distance and the time both proportionately changed. So that's why Aries is a decent refutation, or maybe one of the best.
That's how that's why they developed the whole contraction, where the interferometer was contracting, came up with the Sagan effect, and et cetera, et cetera.
Right, so you have to claim that they change proportionately, which is
that's why Einstein came up with relativity. My bad.
They're like distance and time, when it comes to this, are like sentient and compassionate to the experimenter. They do whatever you want them to do, so that way, you can say that it's moving, but it's really hard to demonstrate that.
Didn't they also bring up the fact that wouldn't Snell's law, shouldn't that also come into play, especially with the incident angle of the light rays when it hits the water in the telescope?
Oh well, if I'm reading Franco's argumentation properly, both Snell's law is accounted for and Snell's law isn't accounted for. So I don't know.
That one kind of threw me for a loop. Like when it's like, whoa, you're right. Like, what about Snell's law? How come did they consider that or not? Like, I was like, but he angled the telescope so it was basically parallel to the star, and I think that would account for most of that if there would be any kind of refraction. But
really good presentation on Airy is done by Stone, and if you go to this video, it's more like a PDF in the way that it goes. Basically, you're gonna have to pause it a bunch to read, but Airy was not like some rinky-dink scientist. This guy was a very accomplished man. He did an insane amount of things. He was knighted. Random things too that you're not gonna expect. He Sir George Airy, he helped optimize the teeth of gears in his time. This guy was just a powerhouse.
Sweet, dude. Yeah, I didn't know that. You got knighted, dude?
He used optics to correct for astigmatism, and he suffered. He discovered that he suffered from astigmatism in one of his eyes. Determined proper shapes for cogwheel teeth. Devised the alt-azimuth style of the telescope. I mean, and the reflex zenith tube style of the telescope. There's just an insane amount of accomplishments that this guy did. Determined longitude at Valencia, Cambridge, Edinburgh, Glasgow, Brussels, and Paris. I think he also found the border between Canada and the U.S. Like, this guy wasn't just some like random, science guy in his own lab. He did so many things.
He founded the border, dude?
He resolved the border between Canada and the U.S., the 49th parallel. And this was all stuff that Stone found on his, not all stuff, but a lot of stuff that he found on his, I'm losing the word. What is it called when someone passes away and then, there's a whole page written about them?
Arbitrary?
Yeah. Obituary.
Obituaries.
Yep. So I posted that in chat. That's good. Alan has a good presentation on it. Apparently John has a refutation. I'm interested to hear them get into it because they know it way better than I do.
So yeah, the Aries failure thing, it's like, I mean, we're talking special relativity here, and like my understanding of it is that like this was like a cornerstone for him because like the explanation is actually like it made it sort of elegant, where they thought that like the relative motion of the earth through the ether would affect the light when it entered the water, but when they found that it didn't, that sort of confirms this idea that like the c from E equals mc squared, is constant regardless of the medium and the inertial plane of the observer.
This is
Right,
all
so
based on the
Yo,
assumption.
real quick.
Hold on.
Wait,
Yo,
let me
real quick.
respond to that real quick. So if the c is constant, right? The speed is constant, then you're claiming that the time and the distance, right? They change proportionately together, right? So if light travels slower in water, then the distance would have to be extended if the c is constant.
Or the time would have to be longer.
Yo, real quick. Yo, was it Witsit or was it Shane when McToon was playing with his cat? This was the exact topic that they were having. And McToon brought up special relativity as a rationalization for
Correct. I posted that in chat. Wait, hang on,
you
Big Tech.
did?
You said or the time would have to be longer. They both have to be longer. They both have to proportionately change. Like V equals D over T, right? So if one changes, then the speed isn't constant, right? If the T changes, if it's a longer time, the V would be smaller. If the D changes, if it goes up, if there's a higher or I'm sorry, am I getting that wrong? Velocity equals
You're saying velocity?
Yeah.
Mm-hmm.
Or I guess the speed is distance over time. So they have to change proportionally.
When you increase velocity, time slows down.
Proportionately, it's sentient and compassionate for some reason.
That's a funny way to say it.
One important caveat to this whole experiment is the assumption is that when a star is at 90 degrees zenith, that it's in an actual position and there's no refraction occurring.
Oh, this is another, you know what, you just reminded me of one of the others. It's the celestial sphere itself as it appears. Like, I can't comprehend how you can get something that's directly overhead at the North Pole, which we would call Polaris, on a flat plane. How do you get that down to 90 degrees from the horizon? Like, how do
What's
you
the
get that?
radius of the celestial sphere?
In your concept or what?
No, that's the whole thing. The celestial sphere is an abstract concept. It's not a thing. It doesn't have a radius value. It's nothing. It actually assumes all the stars are in an apparent location at an equal distance from the observer. It's not proof of anything.
Right. So in order for everything to work in your world concept, my understanding is that, like, we just have to go like, I don't know what that is.
No, people are physically modeling it at this point, and we invoke a dome. And so domes create crazy light refraction. And then you have a personal dome of vision, like you have an amount that you can see on the Earth.
Isn't that far out though? It's like you can go, I invoke a dome, which creates crazy light refraction.
It's inductively proven.
But then, like, later in another conversation, it'll be like, how come I can see a couple miles past the curve? And if I say refraction, it's like, oh, very convenient. It's
No,
like,
we're all good with that, dude. I'm not in the business of giving you that argument. I haven't even given you that argument that we see too far. That's not what I was saying. I agree refraction exists. But if you step into the flat earth worldview that says in order to have gas pressure, it requires containment. So we invoke a container, right?
Oh, I totally deny that too.
Off of inductive reasoning, because you can't show us anywhere in the world or any time that you can have gas pressure without a container. So then, therefore, there must be a container. And then if that container exists, that container would have effects on the lights in the sky, right? You would agree?
I mean, if I followed your logic, which I think had a flaw in it, if I followed your flawed logic, then I would agree.
Okay, point out the flaw in my logic.
In his logic.
The flaw is this. when you say that gas has to have a container,
I said gas pressure.
Right, gas pressure, right? Um, we're running into a word concept fallacy, and this is going to sound like word juggling, but it's actually like we're getting the semantics correct, because the definition of gas pressure requires a wall, not a container. And though those are kind of like synonyms, but it actually requires a wall for the gas to be pressed against. It doesn't have to require containment, meaning it doesn't have to be like surrounded, which is what we really mean by container, but it actually just needs a wall to press against. For example, like a propeller blade creates gas pressure. That's just a wall, the blade itself, that's pressing against gas. That's not containing the gas. It's just the gas pressing against a wall.
Okay,
So
we
what
don't
you need
have
for
that
gas
in the
pressure.
globe model,
Hold on,
though.
hold on.
We don't,
No,
hold on, we
I'll
don't have that in the globe model because
We
it's
do.
a
we have
technical though.
something that's not a force. We have something that's not a.
Tor, real quick, just the word constant. Add constant pressure because he's making a semantic argument for no reason.
So
you get what he's saying.
no,
Like uniform pressure, like equilibrium, right? A blade moving.
Wait,
come on.
We're talking about a
you're jumping
system
again.
here,
You're
though.
jumping ahead.
We're not talking about a paddle or a propeller pushing or pressing against the gas. We're talking about containment, pressure within a system.
I'm going to answer all this. Let me cook. It can't be me against everybody if everybody's going to go equal time. So what happens with the propeller, right? We have motion, and the motion causes an interaction between the gas and that wall, the wall of the propeller blade. The motion and an interaction between the gas and the wall. What do we have at the surface of the Earth? We have motion, 9.8 seconds per meter, for 9.8 meters. I'm sorry, I've been up all night. Meters per second. That's the motion, the downward acceleration that we call gravity. That's motion of gas toward a wall, which is the ground. So the gas presses against the ground. That's the wall. There's your gas pressure. The wall is the ground.
There's no force there. There's no force there. Well, gravity is not a force.
Well, that's not required, actually. All you have to have is motion against a wall.
How do you have motion without a force?
Well, that's a good question.
That is a force.
So quibbling about whether or not gravity is a force or not.
Am I coming through or not? I must be out of why. Am I coming through or not?
You are coming through, sir.
But
so that is force.
That is.
Yeah, well, I'm on his side. That is force because force is just weight times acceleration. Air has weight or mass, and 9.8 meters per second is acceleration. So there is force there.
There you go. So there is a force. There's a surface. There's a force being exerted against the wall, which is the surface of the Earth. So that's
we agree.
So that's the containment.
That's not the argument. According to relativity, gravity is not a force. We agree there is a force.
So the point is, like, now we're getting into that. This is a truly semantical argument whether or not gravity is a force,
it's not,
and I'm cool with it. But what I'm saying is that all you actually need is motion, which you have with the downward acceleration. Whatever is causing that acceleration, force or not, it is accelerating downward. Nobody disagrees with that. That acceleration causes a collision between the gas and the wall, which creates gas pressure. So we have gas pressure because of a collision between gas and the wall, which is the Earth. Whatever's causing that results in gas pressure.
Right, but this is the problem, bro, that you still don't know the difference between inductive and deductive reasoning. And maybe today will be a valuable lesson, right? Because we've been talking about how we have a more logical position because we can use both all real world observations where you have gas pressure only possible under containment, right? That's what Tor's trying to show you inductively, right? That's a logical assumption, right? That we have, and it is an assumption that there's a container out there. Because the other position that you hold right now, you're trying to justify your position, which is you don't need a container to have pressure, right?
It's actually not.
All you need is downward acceleration that we call gravity, right?
Yeah, let's
but
say it's with its
you
electric
can't
universe thing. It's
manipulate
like
it.
an electric downward gradient.
This last
that
thing,
causes-
last point. You can't manipulate gravity, right? And you can't demonstrate a reality in the lab where you can have pressure without containment. So which one of our positions, which
You mean
one
gas
is more
pressure?
logically consistent? That's what ultimately what you do is
can
the
have pressure
process of
without containment.
elimination, and you narrow down the reality that is more consistent logically, and that would be our reality, bro. That there's a container out there, and yet you mock us and scoff at us.
I'm not mocking and scoffing. I'm just saying
No,
that
I'm
like
saying
you're.
people like you. Go ahead, though.
Oh yeah, well yeah. Your framing is just I just consider it fallacious because we can demonstrate like if you put a 5-pound weight on a scale, there's downward pressure on that scale. It's not a container causing that to happen. It's because of the heaviness of the 5-pound plate. And in the same way, the heaviness of those gas molecules are causing a downward pressing against the surface of the earth,
So
which creates gas pressure. It's just
can I
downward
say
pressing.
something real quick?
Real quick, last thing. Last thing.
Like gas isn't magic; it's just molecules.
Hold on, I just want to clarify for the room that you just tried using gravity, the downward acceleration, as your justification for why we have pressure, atmospheric pressure on the Earth. Just for the room. Go ahead, Dyson.
Yes.
I just want to. I'll let him respond to that, I guess, and then if I have time, maybe I can.
No, my answer is yes. That's what I'm saying.
Okay.
Absolutely.
Do you have an example of 14.7 psi gas pressure in a system without a container?
Well, I'm defining the surface of the Earth as the container, so yes, we have it right here.
No, I understand that's your assumption, but I'm just wondering if there's anything you can substantiate.
No, the answer is no. It need a very big mass.
That was
so,
that was a begging the question. So I just want to show you this proof you have is fallacious.
I don't get it.
The thing is, bro, you have not demonstrated deductively your premise.
The thing in contention is what you're referring to prove your point.
So you're asking me, can I show you another planet that does this?
Yeah, separate example. A separate example is what.
Not another planet.
I'm looking for something terrestrially that we can do in a lab setting, not necessarily you invoking your ad hoc assumptions as proof of anything. Like you could point to other planets, that's not going to do it for me. Is there any real world example you can show me 14.7 psi of gas pressure in a system without containment? Like if you can provide that, I might be inclined to agree with the premise of what you're stating.
But you know he can't provide that.
Well, he seems to think he can.
No, you know he can't. So
yeah, what you're essentially doing is like a word game. This is like this is the breakdown of the type of logic that you're using. This kind of presupposition. It's like, oh, I presuppose that if this is true about the world, you should be able to do it again.
That's not quite true.
If you can't do it again, then it's not happening.
I thought we were talking about science, like reproducibility, not just like shouting dogmas and expecting everyone to go along with your dogma. Like we've got to be able to verify, substantiate, and have reproducibility. If you don't have that, you're not doing science. You're in a cult.
Yeah, I think the argument, if I'm going to steel man it, is essentially that one side says gas pressure requires a container. No, it doesn't. This is all in regards to the gas pressure we experience walking around on the earth or whatever. And then so the side that denies that you can have gas pressure without with a container.
I can turn this around on you. I just realized. I can turn this around on you and completely destroy it. I just thought of this. This is awesome. I'm glad we
go
got
ahead.
here. This is going to be 2 parts. They're very simple. What is the PSI in the stratosphere?
Why do you keep going to something that can't be easily reproduced or substantiated or verified? Like, why do you keep appealing to things that require special pleading?
Well, we know it's next to nothing. Alan, so go big tech. What's your next thing?
So it's next to nothing?
Pretty much.
Can you demonstrate for me, terrestrially, a container that has 14.7 psi on one part of the container and next to nothing at the other?
How tall can the container be?
Tall as you like. Can you demonstrate it for me?
Can I put it up to the stratosphere?
Not from the ground.
So I can make a container as big as tall as this up to the stratosphere.
Yep. When you do that, then I'll believe you.
Well, we have it. Because I could beg the question too and tell you there's a container out there.
You just make up something that doesn't exist? Do it.
Nah, man, it's a logical deduction, bro. Induction. It's
all I'm
how
just
reason,
demonstrating is that
works.
the
we don't
level
hold
of
on.
proof that
Why
you have
do you
asked
always
me
do
for.
yo, listen, bro. You got to stop doing that. You did it to Noah. You're doing it to me.
No, but you got to acknowledge my.
You have this habit of impulsively interrupting people in the middle of their sentence. Please stop doing it, bro. No, for real. You did it to Noah. Noah gave you the mic. He yielded the mic. I was gonna mod that for a second, but I let it go. It's all right, bro. I do it. I'm guilty of it sometimes too, bro. It's all good. But see, I already forgot where I was saying. That's why it's not good to do that.
Well, you kind of overreacted. All you got to say is like, hold on.
Nah, bro. Nah, it's not. I'm not trying to overreact, but I have to check the behavior. Or you're going to continuously, impulsively, incessantly interrupt people.
Nah, you're being a little oversensitive to it, I think.
All right, dude. That's the problem. People hate it when you check people, their ego gets in the way, bro. And you can't be humble enough to just let it slide, bro. Just
No,
we do have rules.
You're just making too big of a deal about it.
Just go with it, bro. Just relax,
dude. Yeah, just let him mod. It's okay. Don't worry about it.
Anyways, what were we doing? What were we talking about, bro?
We were talking about gas pressure gradient.
Yeah, he asked me for an example of 14 psi without a container, and I said, "Can you give me an example of what we experience in reality in a container?" And the answer is no. So I turned it back on you, and your answer is also no.
Oh, yeah, I remember. So, yeah, it's not affirming the consequence or ad hoc reasoning to have a logical inference. There's a difference between a logical inference and ad hoc reasoning. There's a nuance there. Because with a logical inference, where I infer that there's a container, and it is a concept that I haven't substantiated or verified, right? But you also haven't falsified it, and to get into the difference between a logical inference and ad hoc reasoning. There's a scale regarding certainty and also how much reasoning is involved and rationality, because rationality and reason are juxtaposed against logic all the time, and I can't begin to explain to you guys the difference. You'd have to have the passion and philosophy to study it out. But what I can say is that when you use rationality and reason, right, and that's what inductive reasoning is, right? You're looking at reality, you're observing nature and how these natural cycles work and how natural laws work. And in nature, bro, all pressure is under containment. And that means that there must be a container out there. It's a logical inference. It's not ad hoc reasoning. I'm not just making shit up on the fly. Go ahead.
I heard about.
I didn't accuse you of that. Yeah.
Sorry. I'm just going to say I heard about some kind of experiment with ionized gas and magnetic fields, and they created pressure. I don't know much about it. Does anybody else? Right, because that would be forces creating a pressure.
That's true.
It's not exactly the same. I don't know too much about it, but it'd be interesting to look into. Just FYI.
No, it's true, dude. They can direct ionized gas through a vacuum, essentially.
Well, even in a sealed container, there's a pressure gradient. So there's some cause for that pressure gradient.
Yeah.
I think it's the weight of the gas.
Yeah, me too. That's what I think causes the gas pressure on the planet is the weight of the gas. That's what I'm saying. It's not.
Yep.
It's not some wall up in the sky outside. It's the downward acceleration of the gas molecules. Just like everything falls to the ground, they're all falling, stacking on each other. At the lowest part, there's the most pressing. That's why there's more pressure down here.
Yeah, this argument's not about pressure gradients or anything. It's the requirement for gas pressure in the first place.
Yeah, requirement for gas pressure is gas and pressure. It's not a container.
Right. It's pressing against a wall is the definition.
Nobody has mentioned the vacuum yet. Been listening for I don't know how long. Not one mention of a vacuum yet.
Go for it.
Let's hear it.
They don't have a vacuum. Nobody has a vacuum.
Good morning, Nessie.
Good morning. So how about it? It's a vacuum there, right? It's not just a wall, right? You got a vacuum there. So
yeah. And what? Problem?
Big problem. Can you show us a containment of gas in a vacuum, please? You know you can't, right?
Can you show me a containment of gas where there's 14 plus psi next to no psi in a container?
That would be your problem. Why are you asking me to solve your puzzle? That's your puzzle.
Wait,
you
no,
got to
so
solve
you're
that.
asking me to demonstrate what I think's going on in reality. I'm asking you to demonstrate what you think's going on in reality. You can't do it either. Of
course, I can put gas in a container. What are you talking about, dude? I can put gas in a container and show it to you.
And in what part of the container will it have next to no pressure?
What does that have to do with anything?
Well, that's what we can observe in the atmosphere. If you just float up in a balloon, I'm going to show you a part of our atmosphere that has next to zero pressure.
Okay. And?
So we're in a system that has next to zero pressure in the same system where there's a bunch of pressure. Can you show me that in a container in a lab or something?
Buddy, in a vacuum. Don't forget that part. What you're imagining in your head is physically impossible. No matter how much you try. Yeah.
No. Can you, before we go on, please define for me vacuum. What do you mean?
Well, it's not a perfect vacuum, right? It's an area devoid of as much matter as possible, air and stuff. It's not perfectly, but
right.
You know, it's 10 to the minus 12 torr thereabouts. In your deep space, it's 10 to the minus 17 torr.
Yep. Yeah. So that's very little matter. And what do we experience as we go up in the up away from the Earth? Don't we experience less and less and less matter?
Yeah, next to a vacuum, buddy. There's no way out.
What do you mean next to? What do you mean next to?
You don't know that your mythical ball is in a vacuum? You don't know this?
Well, a vacuum is relative to what?
It's relative to being. It's relative to a ball of gas that is impossible.
It's not impossible.
It's physically
false.
It's physically impossible. You know it. I know it. Everybody knows it. So just give it up, bro.
I mean, you can just make a baseless assertion all day long, but
do you know the difference between gas pressure and a gas pressure gradient? Do you know the difference between the two?
No, you're not asking me? Yeah, of course I do. I think this fella is confused about the gradient.
No, you're the ones that are confused. See, you're confused. We're setting you straight. You have a mythical ball of gas in a vacuum, something that's physically impossible. So it's up to you to come up with it.
So what's the torr at sea level?
14.7 psi. I don't know about the torr, dude. Torr is not used yet. We don't use that.
But we do in space.
Torr is how you measure in a vacuum.
That's a vacuum, dude. It's a different metric.
Less than 1 psi.
What's the
so there's 14 plus psi at sea level, and then you go up 1,000 feet, and there's less than that, right?
Yeah,
and then you go up 1,000 more.
On sea level, it's 760 torr.
What's the negative?
Thank you. I knew
what's
that. I
in
knew
space?
it was.
What's in space?
So at sea level, it's 760 torr. And then as you go up, the torr level drops. And then you go up and it drops more and it drops more and drops more.
Yeah.
The further you go,
Answer my question. Do you know the difference between gas pressure and a gas pressure gradient? So so you just basically said it, but what I'm saying is gas pressure is X and delta X is the gas pressure gradient. You cannot have delta X without X coming first. So you need to demonstrate X without a container due to gravity. This gas pressure gradient is a secondary thought. It's irrelevant.
Exactly. First, you need containment in order to have pressure. PSI. No way around that. You can point to the sky and make up stories, but there's no way around that.
First, you have to have a wall to press against.
Correct. You need containment. PSI.
Right. And so I don't know, maybe you came in after that, but we just had this conversation. The wall that it's pressing against is the surface of the earth.
Yeah, this is so weird, bro. Because you keep bringing up a wall.
216, bro. This is like, wow. Is there a gopher anywhere around here?
What happens if there's a hole in that wall or a window open? You know, the pressure changes. So when you need to have relative homeostasis, right? Like equilibrium, you need containment. Because if not, because of thermodynamics or fluid dynamics, if you have any type of extreme pressure differential, like a vacuum of space, you're going to have some exchange, right? And the energy is going to escape.
Yes.
So
exactly.
How do you have the vacuum of space next to any pressure gradient?
It does escape.
Even in your model, in your model, it's like 1% escapes every day, if that.
Yeah.
Of gas.
It escapes as much as it can.
To Narnia too.
This is the good part, right? This is the escape part, is one of my favorite parts. Ask him how fast that molecule needs to be traveling in order to escape. Go ahead, ask him.
I don't know that one.
I'll tell you. 25,000 miles per hour.
Is that right?
That is correct.
Escape velocity.
No, you're equating orbital velocity. You're equating escape trajectory.
Well, I'll even be generous. I'll give you orbital velocity, 17.5. About that. Your molecule has to reach at least that.
I don't think you're right about that. I think you're wrong about that.
Well, you're wrong. What you think and what is irrelevant. Check your model, sir.
No, I don't think that ionized helium or hydrogen molecules that are escaping out into space escape because they surpassed orbital velocity. That's not why.
Well, then you need to do some more studying,
because
sir.
Also orbital velocity is relative to how far you are from the planet too. You're talking about low Earth orbit velocity.
First of all, I was generous to give you orbital. You said escape. Escape velocity in your model is 25,000 miles per hour, sir. You should have a look at your model.
That's escape velocity for what? For spacecraft?
Anything.
Escaping low Earth orbit.
No. Like I said, you need to look into your model. I'm getting tired of having to explain your model to you guys and then do the conversation. Your model for the last time.
Your fatigue is not my problem.
Don't interrupt, bro. You've been doing this all day. Okay? Now, listen and you might learn something. In your model, escape velocity is 25,000 miles an hour, and orbital velocity is 17,500 miles an hour.
Okay. I mean, if you say so. I mean, I got to let you have it because you sound.
I got a question. What would falsify the globe for you, or is it an immovable belief on your part?
What would falsify the globe? Let's see. That's a good question. I haven't really considered that one very much. I guess if you could perform something that would be impossible in the globe, that would falsify it.
Like sending radio waves over great distances without any curvature obstructing them.
Yeah, I haven't seen that done in a way that's impossible on the globe.
This concept though of a vacuum.
Hold on, real quick. So now you want to invoke a container, correct? Because you're going to tell me the radio waves bounce off of something in the sky.
You mean just like ionized plasma in the ionosphere?
Yeah, so that's your container then, right?
Well, I don't know if I need to call that a container. It's like it's a reflective.
Well, is it containing the radio waves or not?
Well, it's reflecting them. I don't think that it
stops
okay,
why aren't they going beyond it?
Do they not?
Depends on the frequency.
Right.
Yeah, so you're saying there's certain frequencies of waves that are contained by the ionosphere.
Okay.
Okay, how do I test your claim?
I don't know. I don't know how to test that one.
So you're in the business of science is all about falsifying things, and you never thought about how to falsify the science you believe?
I've never claimed that I believe in the globe because I scientifically proved it. It's not why.
No, I agree. You I think claim that you don't know anything.
Well, more specifically, I said that the story works better for me. It literally just is a more coherent story.
Yep, and we went over that, right, with the scripture and everything.
We just went over this. What's more coherent, right? The one that can be demonstrated in nature and observed, or the one that can't be demonstrated in nature and observed, both deductively and what's the second? Whatever. Go ahead, dude.
You guys have fun with the unconscious Mason. Bye.
Later, CA.